In exercise 10G, you're going to be finding maximum and minimum values, and remember, you've done that before, and the maximum or the minimum value is the y value at a particular point. And I have no doubt that you fully understand a maximum, the highest point, or minimum, lowest point. The only difference now is you're going to be given a defined domain for x. So obviously if they said the domain of x was all real, then you're just looking to see where the graph goes in terms of a maximum or a minimum, and it's possibly infinity, and the minimum would be negative infinity. And they don't really tend to give that situation all that often. What they do is they might say, find the global or absolute, so the global or absolute maximum or minimum, where x only extends from, for example, you can see here, -2 to +2. Now, when that happens, there's a lot of things to consider. Within that range, you could possibly have a maximum value. So let's think about some of our options. So we're going from -2 to +2, and we could have a maximum. And that would be pretty obvious if the graph looked like that we would be reading off this value here, and we would say that's the maximum in the range -2 to 2. Or you might have this situation where this is again -2 to 2, and your graph did this, but then it did that. So here at 2, the graph actually got that high, which is higher than this maximum value. This is now called a local maximum. And over this domain, this y value becomes your global maximum. So it's really important to calculate the y values at the endpoints, or the extremes of the domain, You can see here back in this one, this would actually be the global min, because although this is a minimum point, at the extreme of -2, the y value here is more negative than the actual y value of the minimum point. I hope that makes sense. I'm just going to pause the video now and write up the solution to this question, and then come back and talk about it. Just before I go through that solution to that example, let's just have a look at this diagram here. It also illustrates what I was talking about down here, in that if we were looking for a maximum or a minimum in, say, the range of x is greater than c and less than e. So we're only interested in this part of the graph, from there to there and to there, just that red section. Now you can see that there is a minimum value occurring here and another minimum there. I guess the fact that we would probably identify this as a minimum, as a turning point, would have helped us in this case, and we would probably just compare the two minimums and realise that the actual global or absolute minimum in this range, C to E, would occur here at C. If that wasn't a minimum, if we didn't know the graph did this, that it turned there, we might think that the graph's continuing on down. If it hadn't been identified as a significant point, a turning point, then we would need to check the value at the extremity of the domain down here at C and actually identify the size of it, basically. And likewise over here at E, and of course we will always have our turning points easily identified. Okay, let's have a look at this example now. It says sketch y equals x squared plus x minus 2. In this domain, minus 2 is less than or equal to x is less than or equal to 2. So we're going from minus 2 to 2. And we have to find the maximum value, the maximum. We know that this is a parabola and it's a positive parabola and it's going to have a minimum. So it's not the minimum value that we're wanting. We're wanting to know the maximum value of this parabola in this domain. I thought that I would identify the turning point, and to find the turning point, well, I could have just simply done minus b on 2a, minus 1 on 2, but I went to calculus and said to find the turning point, solve y dash equals 0, and y dash is 2x plus 1. 2x plus 1 is 0, gives x is minus 2. Now, I've gone on to find those actual values when x is minus 2, y is minus 9 on 4. And then, so that I could sketch it, because it said to sketch, what did I do? I looked at each end. When x is minus 2, I found the y value was 0. And then when x was plus 2, the other extremity of the domain, I found that y was 4. I'm starting to get a bit of an idea, and in between those two is a turning point, a minimum. And then I just did my basics. X-intercepts occur when y is 0. Find my x-intercepts, which occurring at 1 and negative 2. And the y-intercept is when x is 0, and so it cuts at negative 2. Now that's enough information to be able to graph it. You can see I start at negative 2, 0. I come down to my minimum turning point and come back up such that, yeah, I can very clearly see from my graph that my maximum, which is what I was asked to find, the maximum value in this restricted domain would be the y value of 4. I think you should be right now to do exercise 10G.